Hey, hi everyone. How are you? I hope you all guys are doing great. In this video, we are going to see Kafka. Then definitely it is going to be a playlist where we will be covering all things about Kafka. Definitely, like if you search Kafka on YouTube, you will find hundreds of video explaining producers, consumers, topic, partitions, but very few answer the most important questions. Why does Kafka exist in the first place? What's the business need of Kafka? Let's suppose you are trying to build a business, or you are even let's suppose you are chasing some interviews. In which scenario you should use Kafka? So it's not just interview topic. Like every day you some of the world largest companies use it is to process trillions of business events, whether it's placing an order, making a payment, booking a ride, or streaming a movie. Chances are Kafka or a similar event streaming platform is working behind the scenes. Okay, so all over this series we are not going to just memorize Kafka, which generally a lot of people does. We are going to understand the real business problem it solves and build our knowledge from the first principles. Okay, so if you like, this is what we are going to cover in this whole series. First, we will see why Kafka, what's the business problem of it, like what was the problem before Kafka and what how it solves it, so that we can create some interest around it. Then we will go to Kafka architecture, topic and partitions, producers, consumers and groups, offset, replication and fault tolerance, delivery guarantees, Kafka internals, and then we will see some practical demos like in the form of project. I will try to make it. Okay. But first, let's see why even we should. Do we even learn about Kafka? Like Kafka it's isn't just I can say another technology we just study for interviews. It's mostly like today over 80% of Fortune 100 companies uses Kafka. Some of the world largest organizations process millions of messages every second. This is fucking huge number, okay? And LinkedIn alone has publicly shared deployments processing more than 7 trillion messages per day. So the real question isn't what is Kafka. The real question is what problem is so difficult that companies at this scale rely on Kafka to solve it. Okay, because if some companies of this scale is relying on Kafka, then definitely it is something good. Okay, so let's see. Okay, first of all, we will try to understand why Kafka is important for our business. Okay, and definitely we are going to take a food ordering system example throughout this whole series. Okay, so let's suppose you are opening a food ordering service. So the architecture, like there will be a user, they can there will be order service, it will do some payment, notify restaurant customer, delivery partner services, analytics service, and invoice generation. So the architecture will look something like this. There will be a user, they will place some order and it will call payment service, and once payment is done it will notify restaurant and customer, delivery partner service, invoice generation, and analytics service. Okay, definitely this architecture looks perfect, isn't it? Okay, but there are multiple caveats in it. Okay, first of all, suppose this notification server is down. So the restaurant received the order, payment was also successful, delivery partner was on the way, but the customer get or the customer never got the confirmation. So now what does this order service will do? Like this was a problem of notification service. So the business impact is customer thinks the order failed, or customer places another order which leads to duplicate order, customer support calls increases. So this is a business problem, it's not just a technical one. Okay, so, and this is what we call it as reliability issue, because this notification service is not reliable. Okay, what else we can do is, let's suppose this invoice generation takes 20 seconds. Should the customer wait for 20 seconds just because the invoice service is slow? No. This will lead to a lot of business impact, like poor user experience, users abandon the orders, higher timeout rates, and this is what we call as slow service problem if one of the service is slow. Okay, now maybe you will try, you will think like, okay, if notification service is failing, we can retry. But how many time you will retry? Like after how many times you will retry? How after how many seconds? 5, 10, 30? For how long? Okay, how long you will retry? Or where do you even store this failed retries? So, and what if order service crashes even before retrying? So now the order service is becoming much more complex than just placing orders. Okay, its job was just to place order, but now it is in tight coupled with all this service. Okay, so this leads to retry problem. And similarly, let's suppose after 1 month, the business also add a fraud detection system. Like because of AI, a lot of people edit the image and they file a false claim such that they can get some refund. So let's suppose you have to add a recommendation engine, fraud detection system, loyalty points. Again and again, you need to modify the order service because there is a tight coupling. Okay. Now, another can be like, let's suppose it's a Friday night, 1 lakh people places orders in a few minutes. Each order triggers, let's suppose, 5 downstream calls. Now, your order service is handling around 5x, which is 5 lakh outgoing requests. Okay, in addition to processing incoming orders also. So even if those all calls are asynchronous, the order service will still responsible for like managing connections, handling failures, tracking retries, waiting for acknowledgements. So this create a bottleneck in scale. Okay, so bottom line, if you think about this architecture and all, there are a lot of problems, but one thing you will find in common is order service has only one responsibility of creating order, but it is handling a lot of other services. So it should be only thinking about order creation. It should not take care or think about the other downstream functionality here, like payment service, notification service, delivery partner service, invoice generation service, analytics service, and all. The order service should be only responsible for creating order. That's all. So now here comes the OG Kafka. Now here how the new architecture will look like. Okay, so now if you see user will be there will be order service, but it will create an event and it will move to Kafka topic, and then it will be consumed by payment service, notification service, delivery partner service, invoice generation, and analytics service. So we will see each and everything one by one, like what is a publisher, Kafka topic, and a lot of things. Okay, but as of now, this is how it will look like. So the order service now doesn't care like who needs this event. Okay, it just simply announces an order has been created. Any service interested in that event can consume it independently. As soon as some order will be created, other services will be ready to consume it. Whoever is dependent on, or you can say whoever is listening to that announcement. Okay, so that this is just a mindset shift. Okay, so what you can think is Kafka isn't introduced as a technology. It's introduces or it was introduced as an answer to a business problem. How do we reliably notify multiple independent services without making order service responsible for all of them? Okay, so we started with a very simple architecture, then we slowly moved to a better architecture. Okay, and let me tell you more about Kafka. Like, it's the architectural idea is event-driven architecture, because as soon as an event is created, this architecture is coming into play. And in this event-driven architecture, if you don't know about event-driven architecture, it's a software design pattern, you can say, where services communicate by publishing events. Okay, instead of directly calling each other. In the previous one, it was directly calling each other, but it is dependent upon the event. So that's why we call it as event-driven architecture. Okay, Kafka is one of the most popular technologies used to implement it. For better analogy, you can think it like if you are aware about MVC pattern or MVT pattern, these are some patterns for better software um, design, you can say. But the framework is who are using that MVC pattern is a Spring, Flask, or anything. So similarly, event-driven architecture is kind of similar to MVC, and Kafka is just one of the most popular technology which uses that event-driven architecture. So here MVC, you can compare it with event-driven architecture, and Flask or Spring, who consume you can you can think similar to Kafka. Okay. Now, I always believe we should understand the backstory of any technology that we are studying, so that we can have some interesting thing around it. Okay. So we have seen what actually Kafka is. Okay. Now, these are the peoples like back in 2010, engineers at LinkedIn basically had a problem. Like millions of users were viewing profiles, sending messages, liking posts, applying for jobs, updating feeds. Every action generated an event. Those events had to be consumed by many systems like search index, analytics, recommendations, newsfeed, job search, data warehouse, monitoring, a lot of things. Okay, so as existing systems couldn't reliably handle LinkedIn scale at and real-time requirements, so engineers from the left, Jay Krabs, Jun Rao, and Neha Narkhede, sorry if I'm pronouncing them wrong, built a new distributed event streaming platform inside LinkedIn, and later it was open sourced, I guess, in 2011, and became a Apache Software Foundation project. That's why we call it as Apache Kafka. Initially, it was just Kafka. Also, um uh, I sometimes I like how this name came. So this name, I guess it was revealed by Jake Krabs only. Like the names came from a famous writer, Franz Kafka, because Kafka was a system optimized for writing, okay, events that are continuously writing to a log. So that's why he kept this name. So Jay perhaps admired Franz Kafka's work a lot, so that's why the name was short, memorable, and sounded good for an open source project. So that's why they name it as Kafka, and that's because it was acquired. It was later open sourced, so that's why we call it as Apache Kafka. Okay, so that's it about Kafka. I hope you might have understood what why we actually need Kafka, why business need Kafka, why even a good-looking architecture fails, and what are the caveats and how Kafka solved it. Definitely, we are going to see a lot of things in future. We have also seen the history of Kafka. We are going to see a lot of things, Kafka architecture and all, where I will try to explain uh, superficially what are producers, clusters, groups, brokers, topic, and a lot more things are coming. Okay, so we have covered why Kafka. In the next video, we are going to see Kafka architecture. So I hope you like this video. If you have any doubt, let me know in the comment section, and I will be happy to help you. And meet you in the next video where we are going to see Kafka architecture. Thank you. Have a great day.